Dear students, welcome to my YouTube channel. We are discussing module 4, which is curve fitting and statistical method. Curve fitting means the construction of mathematical function for the table of data. Means the method of obtaining relation between independent variable and dependent variable in the form y is equals to f of x. Right. In statistical methods, we have to find the correlation between the different two or more independent variables. Suppose z is a function of two variables f of x comma y, then x and y are independent variables. So in statistical methods, we have to discuss about the method of defining relation between two or more independent variables. That is the concept called correlation. Yes, in statistical methods part, let's see the concept of correlation and regression. Here, the aspect of interrelation between two or more independent variables is called correlation. It means that suppose z is a function of two or more variables. Here, suppose assume that z is a function of two variables x and y. Then the method of obtaining relation between independent variables x and y is called correlation. Here, if two variables x and y are related in such a way that increase or decrease in one of them corresponds to the increase or decrease in the other variable, then we say that the variables are positively correlated. Similarly, if increase or decrease in one of them corresponds to decrease or increase in the other variable, then it is called negatively correlated variables. For example, suppose x is a population of a country and y is equals to pollution in that country. Here clearly, if the population increases, then pollution of the country also gradually increases. Similarly, if the population is in control, means it is in decreasing, then pollution also decreases. This relation between independent variables, is called correlation. Similarly, another example, if x equals to time, y is equals to population of a country. If time increases, then correspondingly population of a country also increases. Similarly, these two are the examples for positively correlated independent variables. Let's see one more example. At x equals to time, y is equals to water level in a tank. Here, after some time t, the water level is decreases. If time increases, water level decreases. So this example is this is the example for negatively correlated variables. Yes, sir. Now we can measure the numerical value of correlation between any two independent variables by the formula. Here the numerical measure of correlation between two variables x and y is known as Pearson's coefficient of correlation, defined by R is equals to summation of x into y divided by square root of summation x square into square root of summation of y square. Here capital X means x minus x bar. Here x bar means sum of x values divided by n. N means number of values. Similarly, capital Y equals to y minus y bar. Here x and y are the values given in the table, and x bar means summation of x values, sum of x value divided by number of values. Here y bar means sum of y values divided by number of values given in the table. So by this equation we can obtain the correlation between the two independent variables x and y. Here alternative formula for the correlation is defined by this formula. So you have to remember either this one or this formula. Here R is equals to sigma x square plus sigma y square minus sigma x minus y square divided by 2 into sigma x into sigma y. Here sigma x square equals to summation of x square divided by n minus x bar square. Here x bar means sum of x values divided by n. Is it clear? Here x and y are the values, independent variables, the values given in the table, right? So we have to find out these values. Here sigma x square and sigma y square, sigma. Here for sigma x minus y square, we have to take z is equals to x minus y and z bar means x bar minus y bar. For that, sigma x minus y square equals to summation z square divided by n minus z bar square. Next, there are two properties of correlation coefficient. Here, the coefficient of correlation numerically does not exceed unity. It means that the value of correlation is between -1 to +1. If r equals to -1 or +1, we say that x and y are perfectly correlated. And if r equals to 0, then we say that x is non-correlated. Next, the concept of regression. Regression is an estimation of one independent variable in terms of another independent variable. Means if x and y are correlated, then the best fitting straight line in the least square method gives the relation between x and y. Regression means that the relation between independent variables. We can find the equation for x in terms of y. Similarly, we can find the equation for y in terms of another independent variable x by using the formula. Here a derivation is not included for your syllabus, so that I am giving the formula. Y minus y bar equals to r into sigma y by sigma x into x minus x bar. This is the regression line of y on x. Similarly, equation 2, this is the regression line of x on y. So the coefficient of x in 1 means this term, and coefficient of y in equation 2, this term. These two terms are known as regression coefficient. Here the product of these two regression coefficients equals to r square, because here r into r square. Here sigma y by sigma s, here is sigma x by sigma y. Therefore these four terms get cancelled. R into r square becomes r square. Here the product of regression coefficients is r square, and the value of r equals to plus or minus square root of coefficient of x dot into coefficient of y. This r is called geometric mean of the regression coefficients. Next, alternative formula for regression lines. For this line, this is the formula. Similarly, regression on of x on y is these two are the alternative formulas. Here capital Y means y minus y bar, capital X means x minus x bar. We know that x and y are the small x and small y are the values given in the table. X bar means sum of x values divided by n, and y bar means sum of y values divided by n. So, and similarly these are the formulas. Let's see one problem. Compute the coefficient of correlation and equation of regression lines for the data. This is the table of data given. Here x values in the first row and y values in the second row. Here consider the formula of coefficient of correlation. So here capital X means x minus x bar. Capital Y equals y minus y bar. X bar means summation x by n. Y bar means summation y by n. So to obtain summation x and summation y and capital X and y values, we have to construct the table of values. Here in the first column, write down the values of x. Similarly, second column, write down the values of y. Find out their sum. Sum of x, sum of y. Substitute into formula x bar, y bar. Sum of x divided by n means number of values. Sum of y divided by n means number of y values. Here, x bar gives 4. y bar equals to 11. Next, here to find the correlation coefficient, we need summation of x into y, square root of x square, square root of y square. For that, find out x. X means x minus x bar. Here x bar value is 4, x minus x bar. So 1 minus 4 is minus 3. 2 minus x bar is 2 minus 4 is minus 2. 3 minus 4 is minus 1. 4 minus 4 is 0. So we have to find corresponding value of x, capital X. Here capital X means x minus x bar. Subtract 4 from all the values of x. So we get capital X. Similarly, capital Y means y minus y bar. Y bar is 11. So y values are here. Subtract 11 from all these values. You will get this column. Find out their product and find out the square of x value, square of capital Y, and find out their corresponding sum. Substitute into the formula given in equation 1. So you will get R. Sum of xy is 26 in the numerator, divided by square root of sum of x square is 28 into square root of y square is square root of 28 equals to value is 0.93. This is correlation coefficient value. Next, regression lines. Write down the formula and substitute the values. Here y means y minus y bar equals to summation of xy is 26, sum of x square is 28, x means x minus y bar. Similarly here x means x minus y bar, y means y by y minus y bar. So here also substitute the values, sum of xy, sum of y square. So here this value is 0.93, multiply the terms. Here y bar is 11, x bar is 4, substitute all the values and keep y left side and transfer remaining terms to RHS. So we get y equal to 0.93x plus 7.28. Similarly here keep x in the LHS and transfer minus 4 to RHS. We get 0.943 into y minus 0.93 into 11. 0.93 into 11. Here minus 4 transfer to RHS becomes plus 4. So this value is 6.23. We get two equations. Equation of y in x and equation of x in y. These two are the regression lines for the given data.